Hello everyone. In this video, we are going to solve the problem number 1.22 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. The velocity of a particle moving in the positive direction of the x-axis varies as the function v is equal to alpha root x, where alpha is a positive constant, and assuming that at the moment t is equal to 0, the particle was located at the point x is equal to 0. So let us say this is the point at which t is equal to 0 and x is equal to 0, and the particle is moving in the positive x direction because the velocity is given as alpha root x and x can only be positive. And here alpha is the constant positive constant. Okay, now in the first problem it is asking to find the time dependence of the velocity and the acceleration of the particle. Now if we write the velocity as dx upon dt, where x is the displacement, that we can equate it to alpha root x. And if we take the root x this side, then we can write dx divided by root x is equal to alpha into dt. Now integrate both sides. Let us say at the time instant of t is equal to 0, particle was at x is equal to 0, and at the time instant of t, let us say particle is at the position of x. So we can integrate from x is equal to 0 to x and t is equal to 0 to t. Okay, now we know that the integration of x to the power n with respect to dx is equal to x to the power n plus 1 divided by n plus 1. Similarly, we can write it here x to the power minus half plus 1 whole divided by minus half plus 1 from x is equal to 0 to x is equal to x is equal to alpha times t, and t is varying from 0 to t. So here we will get x to the power half divided by half is equal to alpha times t. So we will get x to the power half is equal to alpha t by 2, and if we square both the sides we will get x is equal to alpha square t square by 4. So this is the value of the displacement or the position we got here. Now it is asked to find the time dependence velocity. So for the velocity we can write v is equal to dx upon dt is equal to d by dt of alpha square t square by 4. As alpha square by 4 is constant, we can differentiate t square, and the differentiation of t square is 2t. So we will get 2t times alpha square by 4, that is equal to alpha square t divided by 2. Now for the acceleration, we can differentiate the velocity with respect to time. So d by dt of alpha square t by 2, and alpha square by 2 is constant, so we can take it outside of the differential, and then differentiation of t is 1. So we will get alpha square by 2. So this is the value of acceleration we got here, and we can see that this acceleration is the positive and it is constant. Okay, in the second part it is asking to find the mean velocity of the particle averaged over the time that the particle takes to cover the first s meter of the part. So we have seen this earlier, that when we are having the constant acceleration, in that particular case we can write the mean velocity as the initial velocity plus final velocity divided by 2. Let us understand this. For example, if the acceleration is constant and it is positive, in that case the velocity will vary linearly from the initial velocity to the final velocity. Then the mean velocity will be this one, and this we can represent it as v mean. Let us say mean velocity is equal to vi plus vf divided by 2. This is for the case when acceleration is constant. Let us say the acceleration is not constant. Acceleration is not constant. Then in that case what we can do, for example, let us say the velocity is as a function of x, then the mean velocity we can write it as velocity into dx integral whole divided by dx integral for the domain of interest. Now if the velocity is a function of time, then the mean velocity we can write it as v of t into dt integral divided by dt integral. So this is the case when the acceleration is not constant. If acceleration is constant, then we can directly take the average of the initial velocity and the final velocity. Now what is initial velocity? That is velocity at x is equal to 0. Okay, because at the time instant of t is equal to 0, it was at x is equal to 0. At that point we can write alpha root x at x is equal to 0, that is equal to 0. What is the final velocity? That is at the distance of s, that we can write velocity at s is equal to, velocity at x is equal to s. Then we can substitute in the alpha root x at x is equal to s, that is equal to alpha root s. Now the mean velocity we can find as mean velocity, let us say Vm. We can write it as Vi plus Vf by 2 and then 0 plus alpha root s by 2, that is equal to alpha root s by 2. So this is the value of mean velocity we got here. I hope the entire procedure is clear. Thank you.